Hey, what's going on? As you can tell, I decided to take a walk down to the beach, the local one. No, just kidding. Um, just messing around with some of the settings here. So, for jokes today, what I'm going to do is I'm going to share some. I'm going to read some to you actually at the start, and then um, you have to wait till the end or fast forward, whatever you want to do to figure out the answers. But I got three of them to start off with. What do you get from a pampered cow is the first one. What do you get from a pampered cow? Second one is, what did Mr. and Mrs. Hamburger name their daughter? And the third one is, what language do pigs speak? All right, it's kind of windy and breezy, so I'm actually gonna head back to the classroom. So there we go. That's a little better. Today's lesson, I think about it that I'm always at the beginning like, oh, well, this isn't new information, and you guys are just, you already know this. And you do. I'm not lying when I say that, but I realize that I probably say that more than you actually feel that way. So, quick story about that. On Sunday, I was disc golfing, something that I do to entertain myself and actually get out. And my wife's brother, he's like 10, just turning 10, and he was doing pretty bad. And he's like whining and complaining that, oh, well, I'm not going to do good. I'm not going to get par. I was like, well, if you think that, then you definitely won't. But I said, if you think that you might, then there's a chance. But if you don't think you will, then you definitely won't get par. And I told him that, and he's like, no, I don't believe you. And he got par on the next one. So that's why I'm telling you that you already know this stuff, and it's not new information. So you can think of it that way. All right, today, lesson 92 is taking a concept of area and expanding that a little bit and taking the concept of area. You understand area on a shape like this. It's the length the whole way that way times the width, and that gives you your area. But then what happens if you only know some of the dimensions, or the dimensions can change? For example, if you're a landscaper or a designer and the person's like, hey, these are the drawings of this room, but we might shrink it 10 feet, might add 5 feet on. Can you design something for it? And then you need to calculate for if they expand it, shrink it. And there's some ways you can do that here. All right, so I'm just going to start off, and we're going to see what we can do here. So it says areas of rectangles with variable dimensions. I mean, in other words, they can change. Variable means you're going to stick a letter in instead of a number. So for this shape right here, I split it up into actual sections. That way you can visualize it a little better. So for these, you can tell this is 3 whole pieces of paper. So I'm just going to do that. I'm going to write 3 above there. And top to bottom is two whole pieces of paper. So I'm going to write that in as well. So as you can tell, you have a shape that is 3 by 2, but then there's these odd sections that go out around here. Obviously, this is a rectangle if you stick them all together. But so this is 3 papers by 2 papers. And then here on the end, this is, I think it's about a third of this actually. So you 1, 2, I think this is about 1/3. So I'm just going to do 1/3 because that's the measurement compared to paper-wise anyhow. And then top to bottom, you still have, I'm just going to take these two. So this is 1/3, and then this is the width is still 2, just like over here. So I'm going to put 2 there. And then down here, this is, I think I cut it in half. I might have got a little bit more, but I was going for half. So this right here is about half of this one. So we're going to write 1/2. And then obviously this is 3 whole pieces as far as that one. So I'll write 3 there. Now you have this little oddball piece down here. And I know it looks like a square, and I think it might actually be, so that tells you how bad my measurements are as far as cutting it off. But obviously it's as wide as these going down through. So this measurement right here is 1/3. And it's as wide as these coming down through here. So this is 1/2. Now, if I told you, okay, go ahead and figure out the area of this shape. Go ahead and think about this a little bit to see what you would do. And this is what you should do. Or there's a couple different ways you can do it, but this is how I would do it. I would take the whole pieces first of all. How many whole pieces of paper are there? Well, there's 1, 2, 3, 4, 5, 6. In other words, 2 times 3, because it's a whole 2 by a whole 3. So I'm just going to write, actually, I'll just write it out. This is 1, 1, 1, 1, 1. So right there you have 6 of them. Now, if you come down here, you have, it's 1/2 wide by 1. Because the width of one of these is 1, but it's 1/2 by 3. So all these total what? If you know what the area of this shape right here, it's 1/2 times 3, which is what? It's 1.5, which means that every single one of these, I'll put 0.5, yeah. Each one of these is actually 0.5 because 1/2 times 3, width times length, stopping right here, is 1.5. So this is 1.5 divided by 3 is 0.5, and you have 3 of them. So you add these together, it's 0.5, 1, 1.5. And then over here, you have, it's 1/3 by 2. So if you go ahead, so this shape right here, the width is 1/3, the length is 2. So if you would multiply it together, 1/3 times 2 is 2 1/3 is what it is. So 2/3. So that means that this is, I'll just put, I should have put fraction. Let me go ahead and just do this. All right. So if you start counting these up, we have the whole pieces here. We have 6 whatever units. I'm just going to go blocks. 6 blocks squared. And then for these down here, you have 1/2, 1, 1.5. So we're going to go 1 and 1/2 blocks squared for this piece down here. These 2 pieces here, you have 1/3 plus 1/3. You have 2/3 blocks squared. And you also, then this one down here, this is the trickiest one. Your length is 1/3 and your width is 1/2. So 1/3 times 1/2 is 1/6. I have to squeeze it in here. Actually, let me just put it up here. 1/6 blocks squared. So really, what we did here is we figured out this shape right here, and then we figured out this shape right here. We figured out this shape right here, and then we figured out this last shape. So there's 4 pieces of information that we stuck together, and your answer here for the area then would be 7 1/2 plus 2/3, which is, let me do this, 7 3/6 plus 4/6 and 1/6. So we have 7 8/6, 7 and 8/6, which is 8 and 1/3 blocks squared for this one. Okay, and if you would add, so in other words, if you would take all these small pieces and crunch them together, you would get about 1 and 1/3 blocks out of there, which makes sense there, that information. All right, so what I'm going to do, that's that. And whenever you have a rectangle and the dimensions can vary, this is what you're going to do. It's the same basic idea. You're going to figure out this, 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 and this. 4 pieces of information. And I'm just going to show you how that works here. Let me erase this board and we'll start over. All right, I want to quick throw some information up here. That way you can, based off the last one, so I had 3 and 1/3. So 3 plus 1/3 on the top, that would be your length, because it's your long side. So you have 3 1/3. And then for the width, you have 2 and 1/2. So it's 2 plus 1/2. And so really what you come down and do is you go 3 times 2 to figure out this main section, and then you do plus 3, and these are what, 1/2? No, yeah, 1/2. So 3 times 1/2, and then you have plus 2 and times 1/3. And the last one is this corner piece, which is 1/3 times 1/2. So that's how you figure that out. You, being as smart as you are, would go, this is 3 and 1/3, so you would go 3 and 1/3 times 2 and 1/2 to figure out your area. You wouldn't pull it apart because you know you can just take any number regardless of the decimal or fraction and just multiply the length times the width. So you're already beyond that step. Now, what if I change that up a little bit? And instead of 3 up here, we don't know how many, okay? So I'll just throw a random letter up there, X. That's how many there is. If I told you this is X long, but I gave you a hint, and that was that I'm giving this measurement 2. So X and then plus 2 over here. Now, the width, then, I'm going to tell you that it is Y. I'm not going to tell you what the measurement is because I don't want you to know that yet. So you have, and I need to give you this information. So I'm going to say that this is, my measurements aren't right today, but I'm going to say this is plus 4. So the measurement of this is 4. The measurement of this is Y. We don't know. The measurement of this right here is X, and the measurement of this right here is 2. So how in the world are you going to get a simplified answer of the area here? Well, if we back up and do just like we did before, how would you figure this out? This area right here would be, what's the width or the length of this area? It's the letter X. We don't know what it is. So the length of that is X, and the width is Y. Let me just draw these arrows here. That way you can see what I'm referring to. Yeah. All right, there we go. So that's what your length and width is x and y. So you multiply that, x, y. And then, so I'm going to put a shape with this. I don't know that I can do it. This is 1. I'm just going to label it 1 because that's this area right here. And then let's say we take this section right here, take these 3 pieces, and it's the width is 4, but what is the length? The length is this right here, because if you take this shape straight down, x would go down here. So I'll put x there. So what is it? It's 4 times x, or 4x, okay? So that takes care of this shape. Let me just label these. If this is 1, shape number 1, this is shape number 2. And then along the side here, you have a width of 2. What is your length? Your length is y from over here. So it's 2 width times length, 2y. 2 times y. That's the third. And then your last shape, which is shape 4. What's the length and the width here? The width is 2. The length is 4. So finally come to a shape that you can actually figure out, which is 4 times 2. Okay? So let's simplify this. X times y, can you simplify it? Nope, you can't. So we have xy. 4x, can you simplify it? Nope, you can't. What about 2y? Can't do that either. What about 4 times 2? Yup, you can. It's 8. So this right here is the answer to the area. Obviously, you can tell that is complicated and it would be tough to figure out. And you're right, it is. It's very, very complicated here. So let me pause this here. Okay, in your book, actually, they do one thing different, and it makes it a little bit more simplified, and it actually makes sense a little bit more to something that we learned previously, which was polynomials, and specifically a trinomial. They have this shape as a square. So if I would like take these pieces out right here, actually, yeah, let me do that. I'm going to quick do this. There we go. Perfect. So I just got to back up. And so now this is closer to a square. This length is about the same as this. So what they do is this measurement is x, and so is this one. They actually have a square here. Mine's not quite a square, but we're going to roll with it. And then this was 4. This becomes x now. This is positive 2. This is 4. So now we have a little bit different of a problem here, just like you have in your book there, example 2. It is. So what happens here is up top, you have this shape's going to change and this one. Okay, so shape number 1 is actually different as well. Okay, shape number 1 is x times x. Length times width is x times x. What is that? X times x is the same thing as saying x squared, right? That's shape number 1. Shape number 2 then is 4 times x. 4x. Write that in there. Shape number 3 is 2 times x. 2x for that. And then the last shape is still 4 times 2, which is that. All right, can you simplify number 1 further? No, you can't. It's still x squared. What about 4x and 2x? You can add them together. So 4x plus 2x is how many x's? 6 of them. And then the last one is 8. Right here is a trinomial. You know, we talked about those a couple lessons ago. This right here is exactly where trinomials start coming into play here as far as math. Okay, so that's that. You can have varied dimensions with that. Let me hit pause, and we're going to jump right into the next thing, which is products of binomials, which is pretty much what we just did up here, and I'll show you that. Okay, jumping back to about 3rd, 4th, 5th grade math. This is a simple multiplication problem. The way you do these problems is you just look at it and get this number here, and you multiply 3 times 7. All right, then you carry it over, and then you jump over and go 3 times 2, which is 6, and you add these two. 3 times 2 is 6, 7, 8. Literally what you're doing here is 3 times 20. If you replace the 7 with a 0, it's 3 times 20, which is 60, and then you do 3 times 7, which is 21. 60 plus 21 is 81. Then you jump over and go 1 times 7 and 1 times 2. There you go. Then you just add these together, you get 351. Now, with this shape right here, I had split it up earlier, and I had said that it's x and 2. What if we just combine those and go x plus 2 for the width here? And then this side is x, and I had put a 4 down here and just combine that. So your length and your width are written like that. Now, let's just make it a simple problem. We go length times width. So my length is x plus 4. My width is x plus 2. Let's multiply these together. Treat it just like a regular multiplication problem. So here we go. 2 times 4 is 8. 2 times x is 2x. And we'll keep these separate like that. And then we got to jump over and go x times 4, which is what? 4x. And then x times x, which is x squared. And we keep this separate with the multiplication sign. Now, let's just add just like we do. So 8, carry that down. 2x plus 4x is 6x, and then you have x squared. There are 3 different terms, so right there you go. That is one way you could do it. You have, just write this down. Your length and your width is this, and this right here. So that's one way. You could literally write it as a multiplication problem. The other way, and this is the way that is probably going to be quicker, it's definitely going to be quicker, is called the FOIL method. I don't know if you guys ever talked about the FOIL method before, but this is what it is. It stands for something, it's an acronym. And so I could do x plus 4 times x plus 2. Now, if you're looking at this, you're like, huh, I could multiply, but I don't want to. What's the fastest way? Well, this right here stands for some words here. You have first, outside, inside, and last. Right? First, outside, inside, last. And technically, you can move those letters around, but FOIL is a word that they could make with that. So, FOIL it is. So what that literally means is you take the first in this two sets of terms, you take the first ones, which is x times x. So you're distributing here. X times x. I'll draw the arrows just for the effect here, and that's x squared. Then you go outside. So this is the outside. This is the inside. So the outside is x and 2. You multiply that together. Right? X times 2, so you go 2x. Then you go to the inside, which is 4 times x. 4 and x are the 2 inside terms, so you go ahead like that. And then the last one, which is 4 and 2 in these terms, 4 times 2 is 8. Now, like I said, you can do that in any order as long as you get all the terms. So you could go 4 times x and 4 times 2, and then x times x and x times 2. But if you do the FOIL method, which is the first, the outside, inside, last, then it'll put them in a nice order like this, and then you can just combine these two, and then bring the others down. Voila, you get your answer. So that's what's going on there. So jumping to practice set, let's actually do this and figure out what's going on here. So I have D, F, H, and J here. I'll just write FOIL in the middle here. First, outside, inside, last. Or you could say first, outer, inner, last. So first, you have x times x. It's always going to be, if the letters are the same, it's always going to be that letter squared. Then the outside is x and 3. So 3x, because 3 times x. And then the inside, which is 1 times x. And then the two numbers, which is the last, is plus 3. So you combine that and you get x squared plus 4x plus 3. And if some of you have siblings that are doing high school, algebra 1, 2, I forget which one, very quickly you can figure out some shortcuts to figure this out. But you need to learn the basics that get you from there to there. But soon you figure out that, you know what, it's going to be 1x and 3x, so that's make 4x, and it's going to be these two numbers, 3, and then it's going to be x squared. And you can start piecing that together pretty quickly, but you got to learn this out. So for letter F here, you have x plus 3 squared. And you're like, yeah, I don't know. Well, what is x plus 3 squared? It's x plus 3 times x plus 3. So we got to figure this out. First, x times x is x squared. Outside, x times 3 is 3x. Inside is 3 times x. And the last is 9. So this right here turns into 6x. There's your answer. And you might be like, well, this isn't solving anything. It's simplifying it, and then you can do stuff with this as you figure that out. Here, first, x squared. Outside is -3. Right here is the sign that goes with it. Make sure you remember that. So it's -3 times x, which is -3x. Inside, 8 times x, +8. And then outside is it's -3 times 8, which is -24. So now you start seeing these terms come to play. So you have x squared, -3x, +8x, and -24. Simplify that down, you have x squared, -3 plus 8 is +5x, and -24. That's your answer. And the last one here. Here you have the same thing, except the only thing that's different is your sign switch. And you'll see what happens when everything's the same besides a positive and negative. Last is 2 times -2, which is -4. So x squared minus 2x plus 2x. What happens here? The -2x and the positive 2x, they cancel out. So your answer is x squared minus 4. So that's the least simplified problem you can have. All right, that's it for today's lesson. The answer to the jokes that I shared with you. The first one was, what do you get from a pampered cow? You get spoiled milk. Second one, what did Mr. and Mrs. Hamburger name their daughter? Patty. And the last one, what language do pigs speak? They speak swine language. Okay, have a good day.